All right, 5D, number 20, college degrees. And you can't see the question, but we need to look at the graph here, so I've really zoomed in on it. See if I can do this. Estimate the number of college degrees awarded to men and to women separately in 1930. So in 1930, the blue is men. The blue is about this high, which is 100,000 in the middle. That's close to maybe 75,000, not quite 100,000, which would be in the middle. Let's get a ruler here, or something that we can put a line on there. So you can see that in 1930 for the men, right there, looks like it comes out not quite halfway up if you look at that. It's close though, so maybe it's 180,000 or 80,000 or something like that. Maybe you call it 100,000. And then men in 2010 is up here. Let's see, I got a better ruler that's clear, I think. Right. Here. So in 2010, straight across ends up here somewhere about 700,000. Okay, and the women, we'd have to take what the men were away from the height of the women, and the height of the women in 1930 is about there, which is a little over 100,000. So the women are about half of the men. So if you said 80, then it would be 40,000. And then the women go, so the men we decided was 700,000, and the women go up to 170,000. So there's, or 1,700,000. And if the men are 700,000 and 1,700,000, so it's about 1 million women. It's a little under that, but something like that. Decide what decade did men or women earn more degrees in 1980? Men are so much, let's see, let's do a comparison here. This I will use the paper. 1980, from the top of the paper to there is the men, and if I do the women, started on the men, they're almost equal. Looks like the men got slightly more than the women, almost equal. Did men or women earn more in 2010? Women clearly got more than men in 2010. During which decade did the total number of degrees awarded increase the most? So the total is this top line, and it's steepest maybe in the 1960s to 70s. Those draft dodgers, by going to college, thought they wouldn't have to go to fight in Vietnam. Or in 2000 to 2010, when the economy tanked, and so people said, let's go back to school. Compare the total number of degrees awarded in 1950 to 2010. 1950, there was about 400,000 degrees. And in 2010, there was over 160,000, over 4 times as much. Okay? Do you think, over 4 times as much. Do you think the stack plot is an effective way to display this data? And you could add to that however you want. It shows all the information. Some people have a hard time reading stack plots, and so that would be an issue. All right, federal spending. Now I wish I had 2 books, because the questions are on the other page. So I'm going to have to flip back and forth on this one. Okay, so the first question on this one is, find the percentage of the budget that went to net interest in 1990 and in 2012. 1990, went to interest. 1990 is right there. It has a height of that to there. That height, and that corresponds to, over here looks like about little over 10%, probably 12 or 14%. And then in 2012, the interest is less than that. It's only that amount, which is just under 10%, maybe 8 or 7%. Okay, because this is percentage. B, find the percentage of the budget that went to defense in 1970. 1970, national defense. So that's to there, which is about a little over 40%, 41 or 2%. And in 2012, national defense is this much, which is about 20%. So it went from 40% to 20%. Find the percentage of the budget that went to payments to individuals in 80 and 12. Payments to individuals. In 80, it's about, not quite, but almost 50%. And in 2012, it looks like it's just over 50%. So that didn't change much there. There was a period where it was higher, but it's coming down. Okay? That's 21. Next one with a question was 22. Melanoma deaths. So now we got this bigger map here, so let's see if I can zoom out a little bit. That's probably enough. And it says figure 5.8, which is what you can see, shows the female mortality rates due to melanoma, a malignant form of skin cancer, across the United States, as shown in the legend. Female. Discuss some of the patterns you see in the data. What regions of the country might warrant a special study? Well, you can see it happens down here in the south, but that's also where there is more sun, where skin cancer, so it's more sun down here. But we do have quite a bit up here in Maine and some across the border states and in Snohomish County and Washington. It's kind of high. The rest of the state of Washington is down compared to the rest of the country, except right in this area. So that's not due to sun. The sunny part of the state's eastern Washington, they're not there. So I would want to do a study there and figure out why in Washington is it happening so much in some areas and not the rest. And same with some of the areas here. You might want to study to figure out why is, I mean, this is sunny Southern California and Nevada's pretty sunny, so we could understand maybe sun related here. And so we would want to maybe compare some of these areas. Is it to something with the sun or some preference? It's pretty high throughout through here. Pretty high and really high in the blue, so the blue and purple are the worst. So that's all sun belt here. But there's some pockets here that are so strange that would make you want to study those. So that's kind of what I would say from this chart and what it tells me to look at. Okay, that's 22. 23. Contour map. So now I'm going to zoom in because this is a smaller map. And that's as far as it goes. Let's see. So this is a contour map. And it says that there's A and B correspond to summits. So in class I talked about you don't really know whether this is a peak or a valley. but these are even heights rings where if you walked on this, you're walking at the same height. If you walk from A to C, if that's a peak, you must be crossing, every time you cross a contour line, you're losing altitude, so you're going downhill, going from A to C. Does your elevation change more in walking from B to D or from D to F? B to D, we're going to cross, this is all downhill, we're going to cross 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, quite a few lines. D to F, we're only going to cross 1, 2, 3, 4, 5, 6. So this is fairly flat, so we're going to lose more altitude from B to D than D to F. If you walk directly from E to F, does your elevation increase, decrease, or remain the same? Well, it doesn't go up or down enough to cross a contour line, so it's pretty much the same. And it's usually, if this is going downhill, this is continuing downhill. So this is closer to the elevation of that line, as is F closer, so you're probably not going to change much elevation. What is your net elevation change if you walk from A to C to D to A? A to C to D, back to A. You're going to be back at A, so your net elevation change is 0. You've lost a lot of elevation, stayed about the same at that loss, and then gained it all back. So your net elevation should be 0. Okay? That's 2331 was a question. Let's go to that one. Cell phone users. Let's see, that table is here. Shows the number of subscribers in years and display the data both ordinary vertical scale and exponential scale. So to do an ordinary scale, you should know how to put 19, 90, 95, 97, a nice scale across, and put the heights in. And I can do that on a calculator. So let's do that on a calculator. On Stat, Edit. So I'm going to go to list 1 and clear it, and list 2 and clear it, and come back down. And I'm going to put in 1990, 1995, 1997, 1998, 2000, 2001, 2002, 2003, 2007, 2010, and 2012. And where the number of, this is in millions, and we got 5 million, 34 million, 55 million, 69 million, 86 million, 110 million, 128 million, 141 million, 159 million, 255 million, 303 million, 325 million. And so, oops, didn't come out with the same length of lists. What's wrong here? 5, 34, 55, 69, 86, 110, 128, 141, 159, 255, 303, 325. So I'm missing a date over here. 1990, 95, 97, 98. One missing, so I insert 1999. Whoop. 1999, enter. So I got 1998, 1999, 2000, 2001. So now they should be the same length lists. Oops. Yes. So second stat plot, enter. turn on a plot that does a scatter plot using list 1 and list 2 with a cross, and I can go zoom window, zoom stat, zoom 9, and there's the data. Now what happens if we do an exponential? So now exponential will have 10, I should have put these in as millions, but okay, it doesn't really matter. So I can go as 10 to the first, 10 to the second, 10 to the third, 10 to the fourth as my units, as opposed to 1, 2, 3, 4. But I can get a picture of what it looks like if I just go to my stat and edit, and I'll make list 3 clear. I'll make list 3 be the log of list 2, and then I'll be putting the exponents of 10 for each of these numbers. Enter. And so I just figured out the logs of all these. So now I want to graph the year with the list 3. So second stat plot. I'll turn on number 2 and tell it to do a scatter plot with list 1 and list 3. And then I can graph. They all look down here, so if I need to turn stat plot 1 off, and then I can go zoom stat, and we get the picture of that, and it made it curve. Now that's not usually what we do in mathematics, is take something that looks fairly linear and make it curve. What we usually like to do is take something curved and make it linear, so we'd use the log only to straighten out a curved data. Okay? But that's how you do the exponential scale.